The universe is a really interesting place, but let me ask you, where does it end? Where is the literal edge that we can't get beyond? Join us as we explore the question, where is the edge of the universe? Number 8. How do we define the edge of the universe? I know this may sound like an easy question, but trust me when I say that it honestly isn't, and some of it is for reasons that we'll discuss a little later on in the video. But one of the reasons we need to ask this question is that there are some people who don't know if there is an actual edge to the universe at all. After all, to have an edge would mean that you are a shape or object that is actually capable of having an edge. And for a long time, a lot of people felt that the universe was a flat, long object. But recently, some theories have been circulating that the universe might actually be a sphere, which means that there is no edge, but rather an outline of the universe, which of course would change every known theory about the universe as a whole. To be clear, this wasn't just any random idea that came about. Rather, it came from a study of a lot of significant data. Specifically, they looked at the cosmic microwave background, also known as the CMB. What is CMB? Well, it's the remnant light from the Big Bang, and it's the most distant light we can see in the universe. Because of this, it is the light most affected by the shape of the universe. The scale of fluctuations in the CMB is determined by the amount of dark matter and dark energy in the universe, which we know, so we know how large the fluctuations should appear. These fluctuations of light have helped scientists in many ways over the years, and this new team looked at the fluctuations and noticed something very strange, because the data from the Planck spacecraft indicated that the fluctuations of the CMB was much more than it would have been. So if the universe was flat, these fluctuations would not be possible, or at the very least, not to the extent that they are right now. Thus, this new study seems to show that the universe is more rounded than we earlier expected. So if the universe is a sphere, how can we look for a single edge when technically that would be any point along a circular outline? Well, let's not get too crazy with it, okay? Let's just say for this video that we're looking for the place where the universe ends, and there's nothing beyond that. So how do we search for that? Simple, we start at the beginning of it all in the eyes of many. Number 7. The Big Bang. As is somewhat of a tradition here on Earth, there are many beliefs and theories as to who or what created the universe. But in terms of science and the people who live in this realm, they believe that a massive explosion of energy and matter created the universe as we know it. Now obviously, just because that explosion happened means that life and the universe as we know it was fully formed. Far from it, in fact. You see, most scientists agree that after everything settled down from the massive explosion that created it, things began to grow, expand, evolve, and of course change. For example, it may seem logical to an extent that the growth of Earth came rather quickly, but that's not the case. Earth took billions of years, according to scientists, to just get the most basic of life made, and then it took billions of years more to get to where we are now. The same goes for the rest of the universe, because while it may seem easy to think that everything just settled down after the big explosion that created everything, that's not likely. The edge of the universe likely shifted quite a bit before settling down, if it ever settled down at all, given that the universe could theoretically be infinite, something we'll touch on in a bit. That's one of the big reasons that scientists try and not just prove the Big Bang, but try and get a lot of information from its potential origin, because it could prove where the edge is, if one exists at all. Number 6. Dark matter. In the universe, no matter how big it is, there are a few fundamental mysteries that are going around, and one of the biggest by far is that of dark matter. This is thought to be a property of not just the universe, but proof that the universe doesn't have an edge, because it's still growing. You see, scientists believe that the universe had stopped growing after the Big Bang, or at the very least had slowed down from the rapid expansion that created the universe, which would make sense when you think about it, because after a while the expansion would have to stop, right? As the energy or even the momentum of the massive explosion would end, and thus no more growth. But then in 1920, Edwin Hubble made a discovery that the universe was still growing and it didn't show signs of stopping. This sent many scientists into a tizzy because it wasn't clear what would cause the universe to continue to expand. Could the energy from the Big Bang truly have been infinite? Or was something else coming forth to cause the expansion? The answer that was found, in theory at least, was that of the concept of dark energy and dark matter. Scientists believe that dark matter is the reason that galaxies exist as we know them. How does that work when the Big Bang apparently created everything? Simple. While the Big Bang was the creation event, many scientists have noted that galaxies shouldn't stay together in their current forms, meaning they shouldn't rotate in place. Instead, they should just fly apart. But instead, they stay close. Most of the times anyway. There are exceptions to the rule, and become formed objects in space. The reason for this is that dark matter has gravity, and scientists feel that because there is so much dark matter in the universe, up to 85% depending on which scientist you talk to, that the gravity exerted allows them to stay as one. The only problem with dark matter is that it's still a theoretical property of the universe. They can't prove it's real, but they do think that it exists in some part, and that it is the reason that dark energy exists, which affects the universe in the opposite way of dark matter. Before we get to dark energy and its properties, be sure to like the video and subscribe to the channel. That way you don't miss all of our weekly videos. Number 5. How dark energy fits into this. Dark energy is the principle posed by scientists that it's a type of energy that is literally pulling at the universe, thus allowing it to expand. All matter in the universe have a type of gravity, and that holds the universe together. But this dark energy is pulling it apart in a way that counteracts the gravity of the universe without destroying it, which is a good thing, because it'd be the opposite of pulling at something like Play-Doh until eventually it breaks. We currently don't have to worry about that. Dark matter is theorized to be the source of dark energy, not the least of which is because of the whole 85% of the universe may or may not be made up of it. So by that token, dark energy isn't just pushing the universe's boundaries, it's technically doing it in all directions. Furthermore, we don't know if this dark energy is ever going to run out. And due to that, that could mean that the universe is ever expanding, never stopping in terms of its growth, and something that could theoretically never have a single edge to it that we can see, which is already a problem from where we are on Earth, because the universe is way big and much larger than most people are willing to admit, because they don't understand how big a galaxy can be or understand the measurements of light years. Number 4. Light years and how it factors into galaxies. If you wanted to know where we are in this massive universe, I would tell you that you find yourself in the legendary Milky Way galaxy, a place so vast there's a unit of measurement that perfectly defines it: light year. No, not Buzz Lightyear, just light year. In case you're curious, a light year is a distance of 9.461 trillion kilometers, which for the record is already a long distance before you start stacking it. That measurement becomes even more important when you realize some of the things that are closest to us in terms of this galaxy. For example, the next star that we are close to is known as Alpha Centauri, but that is 4.24 light years away. And do recall, when it comes to space travel, Earth isn't exactly the fastest at getting things moving. For example, we made a probe called Voyager 1, and if it tried to make it to Alpha Centauri, it would take 70,000 years, give or take. So yeah, that is a long way away. And then there's the Milky Way galaxy itself, which is actually 100,000 light years from end to end. That would take humanity such lengths of time to go from that point to the other that the universe likely would end before it happened. Let's hope not, but I hope that gives you context. And remember, that's just one galaxy in the universe. There are between, based on who you ask, 100 billion to 2 trillion galaxies that we think we know of in the universe based on our information and knowledge. Number 3. The observable universe. So at this point in time, I hope you appreciate the scale and scope that the universe appears to be in our own eyes here on Earth. Because as we see it, the universe is truly massive and it's still growing. What we define as the observable universe is merely a guess based on our instruments and other devices to try and define what is technically indefinable. In fact, here is the actual definition of observable universe. The observable universe is a spherical region of the universe comprising all matter that can be observed from Earth or its space-based telescopes and exploratory probes at the present time, because electromagnetic radiation from these objects has had time to reach the solar system and Earth since the beginning of the cosmological expansion. But if the universe is infinitely growing and the edge of the universe is continually expanding, that could mean that the light that we're seeing from the universe reaching us isn't the end. It's just one stop on the way to the end, which is a bit of a mind trip. And it's further estimated that the width of the observable universe is about 93 billion light-years across. But that's the rub. That's what we can see in certain ways. But what lies beyond the observable? Number 2. The unknown universe. The reason that we can see what is on parts of the edges of the universe is because the light has reached the Earth. But given the distance and the speed of light, that also leaves the possibility that there are objects beyond the observable universe that is yet to be witnessed by man. Many have speculated what could be out there, but we have no proof to say what is and isn't beyond the lines that we have put the universe in. The unknown is often something we seek to find out, but we are almost always limited by what we have and what we can use to define it all. But either way, if there is more beyond our universe than what we see, it makes us even smaller in comparison. But more than that, there is a theory that between the dark matter and dark energy that is expanding the edge of the universe, that there honestly isn't anything for us to find once we go beyond what is observable. What do I mean by that? Well, think of it like this. Imagine you have a large box of crayons and you're told that the paper you can draw on, let's say a roll of paper, is infinite, and it grows as you draw. The crayons are the energy and matter that was created in the Big Bang, and thus you're drawing the universe. Eventually your crayons are going to run out, right? Which means that while you're stuck at one point, the paper is going to continue, and that's where we're at. If there's nothing in the dark areas of the universe that are continually expanding, if there's nothing to emit light that will reach us, which would take a long time for the record regardless, we really can't know what's out there in the unknown. Number 1. Where is the edge? That's a good question, and it's one that no one really knows the answer to. Again, we only know what is the distance of the observable universe, and even then that logic can't be picked apart because we don't technically know the shape of the universe and how light travels through it. A straight line doesn't necessarily apply here. Plus, if the universe is growing infinitely, then that would mean that nothing is where we think it is in the grand scope, because the outlines of the universe are consistently changing. Now sure, something may happen to where the universe stops growing, and we may, emphasis on may, be able to figure out where the edge is, but that's not right now. In fact, if you wanted to give an honest answer to where the edge of the universe is, you should pull a James T. Kirk and go, there, that direction. Thanks for watching, everyone. What did you think of this look at the universe and how big it is? Did you learn something about the universe at large? Where do you think the edge of the universe is? Let me know in the comments below. Be sure to subscribe, and I'll see you next time on the channel.